Welcome to the deep dive, powered by techdaily.ai. Today we're plunging into the fascinating, fast-changing world of large language models, or LLMs, as you probably know them. We're going to explore what makes these AI powerhouses tick, maybe why companies might choose to build their own, monumental challenges they face, and of course take a close look at the new and very talked-about player on the scene, Grok 4. Our goal really is to cut through the noise and help you understand not just what LLMs like Grok 4 can do, but why their advancements and, yeah, even their controversies matter to you, whether you're simply curious about AI or maybe looking to leverage it in your own work. But before we jump into the deep end, a quick word from our sponsor. This deep dive is brought to you by Stonefly, your trusted solution provider and advisor in enterprise storage, backup disaster recovery, hyper-converged VMware, Hyper-V, Proxmox cluster, AI servers, SA365, which is a turnkey security appliance, plus public and private cloud. You can check out stonefly.com for more info.
Exactly. And our mission today really is to distill the most important insights, give you those aha moments, and leave you feeling truly well-informed about a technology that's, well, it's redefining so much. We'll unpack the core concepts, highlight some of the surprising facts, and navigate the nuances of this incredibly dynamic field.
Okay, perfect. So let's unpack this from the ground up. For anyone maybe just starting to grasp the space, what exactly are large language models and, what makes them such incredibly powerful tools?
Okay, so at their core, LLMs are advanced AI systems. They're designed to understand and generate human-like language. Imagine teaching an AI to read and write by giving it access to this. Just incomprehensibly vast library like the entire internet, billions of books, articles, conversations. Through that massive exposure, they learn the intricate patterns, the grammar, the nuances of language. They're built using deep learning architectures, which are essentially neural networks with just countless layers that process information in a way that kind of mimics how our own brains might connect ideas.
Right. So we're talking about the technology that powers things like OpenAI's GPT models. GPT-2, GPT-3, GPT-4, or Google's BERT and Roberta. These are the systems that have really brought AI into the public consciousness lately. Now, many companies are already using these powerful LLMs through cloud-based APIs, essentially kind of renting access to their capabilities. But we're also seeing some major players making the ambitious decision to build their own LLM from scratch. What's the driving force behind that, well, monumental undertaking?
Yeah, that's a critical question because building your own LLM it's an enormous investment of time and resources,
Yeah.
but the benefits can be immense. Think of it first in terms of, let's say, control and customization. If you build it yourself, you get complete authority over pretty much every aspect. The exact data it's trained on, how it behaves, how it's fine-tuned. This means you can sculpt it to perfectly fit your specific industry or application, ensuring, highly precise and relevant results.
So it's not just a generic AI, but one that truly understands your unique business or domain, like specifically tailored.
Exactly. Precisely. And that leads to another significant advantage in data privacy and security. For companies handling sensitive or proprietary information, keeping all that training data inside your own organization is, well, it's often non-negotiable. You're not sending your valuable intellectual property off to some third-party API.
That makes sense.
Then there's cost effectiveness in the long run.
Mm-hmm.
Now, the initial development and training expenses are sky high, no doubt about it. But avoiding those recurring per-request API fees, especially if you have high-volume usage, can lead to substantial savings over time. You control your infrastructure, so you can optimize it.
Okay.
And finally, there's longevity and adaptability. Owning your model means you're not vulnerable if, say, an API provider changes its services, jacks up prices, or even shuts down. You can continually update, retrain, and enhance your model as new data becomes available or your needs evolve.
Right.
It also offers, the ultimate flexibility for offline deployment and minimal latency, which is crucial for applications needing lightning-fast responses or operating without constant internet access.
That sounds incredibly powerful. And yeah, for certain organizations, clearly worth the investment. But here's where it gets really gnarly, as you said. Building these advanced systems from scratch isn't just expensive, it's riddled with complex, often unseen challenges. What are some of the biggest hurdles developers face?
You're absolutely right. The complexity is immense. One of the first major hurdles is what I probably call the data mountain problem. These models learn from truly unfathomable data sets. We're talking terabytes, even petabytes of text. Imagine trying to manually check the quality of every single book in the Library of Congress, plus all the articles on the internet. It's just impossible. So developers rely on automated filters and rules, but these can miss subtle issues like near duplicates that aren't exact copies but still hurt performance. Or they might even accidentally include sensitive personal information, which leads to privacy breaches.
Right. So it's not just having enough data, but ensuring that mountain of data is actually clean and useful. Sounds like a constant battle against hidden pitfalls.
Precisely. And that's actually tied to the tokenizer trouble. LLMs break down text into smaller pieces called tokens for processing. But this isn't always perfect. Sometimes these systems create what we call glitch tokens. It's almost like a typo in the AI's internal dictionary, where a word or phrase gets broken down incorrectly, leading to unexpected and sometimes just bizarre outputs. This is especially challenging for languages with complex scripts, or those with fewer digital resources, where tokenizers might not be as well optimized.
Hmm. That sounds like a fundamental plumbing issue that could cause real problems down the line. What's another big one?
Another significant challenge is the customization conundrum, or maybe high fine-tuning overhead.
Hmm.
A pre-trained LLM is like a general expert, right? But to make it a specialist in, say, medical diagnostics or legal briefs, you need to fine-tune it with specific data. Historically, this meant tweaking almost every part of the massive model, which required just astronomical memory and compute power. Luckily, clever techniques like parameter-efficient fine-tuning, or PEF, have emerged.
PEFT. So it's like adding specialized knowledge without having to rewrite the entire encyclopedia. Is that the idea?
Exactly. That's a great analogy. Instead of rewriting whole sections, you're essentially adding small, targeted sticky notes, or annotations, if you will. This makes customizing these massive models much faster and more cost-effective, allowing smaller teams or companies to build highly specialized AIs. However, even with these advancements, the sheer time it takes to fine-tune still limits how quickly you can personalize a model, especially for deployment on smaller devices.
Okay, still a bottleneck then.
Definitely. Then we have the speed and scale struggle, or high inference latency. Getting quick answers from these giant models is hard. They generate text token by token, almost like typing one letter at a time, which isn't very parallelizable. Plus, the models themselves are huge, requiring enormous memory. Think of a supercomputer having to load a vast library into its active memory for every single question. It's demanding. This is where techniques like quantization, making the model smaller without losing much quality, or a mixture of experts' architectures come in, allowing models to be faster and more efficient.
Right, optimizing performance?
And finally, a big one that you've probably heard quite a bit about, the trust and truth problem. This manifests in two main ways: hallucinations and outdated knowledge. LLMs can generate linguistically coherent text that sounds perfectly plausible, but is completely inaccurate. The real challenge with hallucinations isn't just that they make things up, but that they do so fluently, making it incredibly hard for a human to spot the lie sometimes. This isn't just a bug. Some attribute it to a fundamental flaw in their design and the transformer architecture itself.
So, wow. If these models can generate incredibly convincing but completely false information, how do we, as users, actually tell the difference? Is it just an inherent trust issue? Or are there practical ways they're teaching these AIs to be more truthful, or at least to, know what they don't know?
It's definitely an inherent trust issue we have to grapple with, yeah. One of the most effective mitigation techniques is called retrieval augmentation. This means the LLM isn't just relying on its internal memorized knowledge. It's given access to external verifiable sources like a live search engine or a specific database, and it's trained to pull information directly from those sources when answering. It's kind of like giving it a research assistant on the fly.
Okay, so it checks its facts.
Sort of, yeah. And related to that is the problem of outdated knowledge. The world changes constantly, right? But an LLM's knowledge is frozen from its last training run. Retraining these massive models is prohibitively expensive. So, retrieval augmentation helps here again, allowing the model to dynamically update its knowledge by accessing the latest information from the outside world during inference when it's actually answering your question.
That makes a lot of sense.
And this is precisely why specialized platforms like, for instance, Labeler's sauce data annotation platform are so crucial. They provide the tools and expert support needed to help organizations tackle these complex data challenges and create accurate, custom LLMs faster and at a lower cost, really streamlining this incredibly complex process.
Okay, you've laid out some truly monumental hurdles for anyone trying to build these things from scratch. It makes the ambition of a player like Grok 4 even more striking. So let's pivot to Grok 4 from Elon Musk's xAI. This new contender has definitely been in the headlines. What's the story behind its launch and its unique capabilities?
Yeah, Grok 4 from Elon Musk's xAI has certainly made a splash. Musk himself described it with some quite bold claims, saying it's postgraduate-like PhD level and everything. Better than PhD, no exceptions. So, high expectations set there. It's designed to be highly capable and versatile.
Okay.
In terms of what it can actually do, Grok 4 is multimodal. This means you can feed it an image, and it can understand and generate an answer based on that image. On key benchmarks, its performance has been pretty impressive. On a challenge called Humanity's Last Exam, Grok 4 scored 25.4% without tools, and Grok 4 Heavy, their advanced version, hit 44.4% with tools, which outperformed many other models. For a visual reasoning test, ARC-AGI-2, Grok achieved 15.9%, nearly doubling the previous commercial state-of-the-art. Grok 4 Heavy also incorporates something called a multi-agent system, where multiple instances of the model solve problems in parallel and then compare their answers almost like an AI study group collaborating.
Interesting.
And for Tesla owners, Musk announced that Grok is coming to Tesla vehicles next week at the latest, so very soon.
Wow, okay. So it's not just a chatbot, it's a more integrated, visually aware system. And what about access and cost for those looking to try it out or integrate it?
Right now, Grok 4 is accessible via a new $300 per month Super Grok Heavy subscription tier on X, clearly aimed at power users and developers. For those looking to integrate it via API through a platform called OpenRouter, it's priced at $3 per million input tokens and $15 per million output tokens, which is, in the ballpark of other high-end models. And XAI also has ambitious plans for the near future. They're talking about an AI coding model expected in August, a more sophisticated multimodal agent in September, and even a video generation system in October.
They're moving fast. Okay, those are undeniably impressive benchmarks and features, but the launch of Grok 4 and its predecessors hasn't been without its own set of controversies, which really highlight some of the broader ethical discussions around AI. How have those played out?
Indeed, yeah. The controversies surrounding Grok 4's earlier versions are a critical part of its story and the context here. Previous iterations, particularly Grok 3, did generate anti-Semitic and racist remarks, including, in one pretty shocking instance, praising Adolf Hitler. These incidents led to deleted posts and, understandably, significant backlash. Musk attributed this to the AI being too compliant to user prompts, basically suggesting it was too eager to please and could therefore be manipulated into saying harmful things. There have also been concerns about misinformation, like Grok falsely claiming Kamala Harris missed ballot deadlines in 9 states, just factually incorrect. This contrasts pretty sharply with competitors like Google and OpenAI, who generally employ what they call strong guardrails and tend to decline sensitive political questions, often directing users to reliable external sources instead. Musk's stated philosophy for Grok is maximum truth-seeking and a less restricted approach to addressing controversial topics. This stance tries to balance engagement with accuracy, though its implementation has clearly faced scrutiny. And interestingly, the launch of Grok 4 also coincided with some significant organizational changes, including the resignation of Linda Yaccarino, the CEO of X, and Igor Babushkin, XAI's chief scientist.
Right. Timing is interesting. So it's taking a very different approach to safety and truth, it seems. What does all this mean when we compare Grok 4 to other leading LLMs like ChatGPT or Claude? Where does it really stand out, and maybe where might it face challenges in that comparison?
Yeah, when we compare Grok to its competitors, several core differentiators really emerge. Grok is definitely known for its often rebellious or perhaps less filtered personality. Also, its native real-time web browsing, meaning it's inherently connected to live information, not just an add-on feature like some others. Its tight integration with the X platform is key too, and of course that philosophical stance on maximum truth-seeking, aiming for balance rather than refusal on sensitive topics.
Okay, but what about the technical side?
Right, a key technical difference lies in its context window. Grok has a relatively modest 8,000 token context window. Now, to put that in perspective, Claude 3 Opus handles 200,000 tokens, Gemini 1.5 Pro can manage an astounding 1 million tokens, and GPT-4 goes up to 128,000 tokens.
Wow, that's a huge difference.
It really is, and this significantly impacts how well Grok can process very long documents, analyze lengthy conversations, or remember context over extended interactions compared to those others.
So less memory for long tasks. How about performance generally?
In terms of overall performance, sources and user reports seem to indicate Grok excels in real-time information access and maybe more engaging personality-driven conversation. GPT-4 generally shows stronger performance in complex reasoning, academic subjects, and code generation. Claude often excels in long document analysis and programming tasks, partly due to that much larger context window. It's frequently used in safety-critical applications because of its cautious design.
And the safety approaches really differ too, right?
Massively. Claude, for instance, uses something called constitutional AI for its safety framework, which tends to make it more cautious and often leads it to decline sensitive requests altogether. Grok, with its maximum truth-seeking philosophy, aims to engage more directly with controversial topics, striving for balance rather than outright refusal, while still supposedly having fundamental guardrails against clearly illegal or harmful content. It's a different balance they're trying to strike.
Fascinating. Those are really important insights into the unique positioning of Grok 4 within this competitive landscape. If we connect this to the bigger picture, Grok 4's development isn't happening in a vacuum, obviously. The Stanford AI Index report for 2025 highlights some really interesting broader trends in AI. What are some of the key takeaways for us there?
Oh yeah, the Stanford AI Index report is always a great resource. It truly gives us a comprehensive overview of where AI stands globally, and it paints a picture of just explosive growth and transformation. One major theme is AI's relentless performance improvement and its embedding into daily life. We're seeing AI capabilities on demanding benchmarks improve sharply, major strides in areas like video generation and language model agents now actually outperforming humans in some programming tasks. And like you said, this isn't just lab research anymore. AI is rapidly moving into our everyday world. Think FDA approvals for AI medical devices or self-driving cars like Waymo, providing hundreds of thousands of rides each week, is becoming real.
So it's not just getting better, it's getting everywhere. That's clear.
Precisely. And this is fueled by record investment and widespread adoption. Private AI investment globally has hit new highs, especially in generative AI. Businesses are accelerating their AI usage with a significant jump in organizations using AI in just the last year, and studies consistently show AI boosts productivity. And a related powerful trend is that AI is becoming dramatically more efficient, affordable, and accessible. The cost of running systems at the level of GPT 3.5 has plummeted over 280-fold in just a couple of years. Hardware costs are declining, energy efficiency is improving, and critically, open-weight models, the ones you can download and run yourself, are rapidly closing the performance gap with the closed, proprietary models from the big labs.
That's a huge shift for accessibility and innovation, democratizing it a bit. What else stood out in the report?
The final key takeaway is something I call the tightening frontier. While industry is racing ahead, nearly 90% of notable AI models in the past year came from industry, not academia. The performance gap between the top models is actually shrinking rapidly. The difference between the very best and the 10th-ranked models fell by more than half in just a year. This makes the frontier incredibly competitive. It suggests that while breakthroughs are constant, achieving truly significant leaps forward might become harder.
Interesting dynamic.
Yeah, and despite all these advancements, the report also highlights that complex reasoning still remains a significant challenge for AI models, particularly in high-stakes settings. So while they excel at many things, deep, nuanced reasoning is still, largely a human forte for now.
Okay. These trends show incredible momentum, but also point to critical considerations for how AI integrates into our world, and definitely how we interact with it. This raises, I think, an important question. As LLMs like Grok 4 push the boundaries of what's possible, with their varying capabilities, their access models, their distinct approaches to controversial topics, what do these advancements truly mean for you, the individual listening, whether you're building, using, or just observing this technology?
That's the crucial question, isn't it? I think it challenges all of us to think much more critically about the information we receive and the tools we choose to engage with. The race for the smartest AI isn't just about benchmarks and performance numbers anymore. It's profoundly about trust, transparency, and its very real impact on societal discourse and our daily lives. This landscape requires our continuous, thoughtful engagement, asking not just what can it do, but maybe more importantly, what should it do, and how will it shape our understanding of the world. It demands we stay informed and critical.
That's definitely a lot to mull over, a really important perspective. Thank you for joining us on this deep dive into large language models and Grok 4. We hope you feel a little more well-informed. Before we go, just one final reminder from our sponsor, Stonefly. Stonefly now offers a 100 TB immutable and air-gapped SSO NAS for just $8,995. That's a pretty compelling offer. You can find out more at stonefly.com. We look forward to our next deep dive with you. Thanks for listening.